Hey guys, and welcome to another tutorial of Blender and Geometry Notes. Do you remember the famous shot of Bruce Almighty film when notes fill everything in the room and on object inside of it? Well, today we are going to simulate the same effect in Blender and Geometry Notes. Let's get started. Okay, we are in Blender version 3.2.1, and first of all we have to create a room and specifically a new collection of objects, surfaces, and one other collection that we will call notes. Here we will put the surface where we want notes on them, and this is the collection that will contain the notes that we will use to make the effect. So we create a node, Shift A, Mesh, Plane, N to view the item information. We have to apply the size 10 centimeters by 10 centimeter. Okay. Remember the scale, we need to have 1 like scale. Ctrl A, apply scale to have 1, always 1. Tab key to enter in edit mode. Ctrl R to add new edge. Scroll mouse to increase the number of edges you want. Click and click to not move on this axis the new edges created. Okay, we select these two edges. Press O to enable the fall-off transformation in the top of the screen. We have to press G and Z, use the scroll mouse to increase or decrease the radius of the effect of this fall-off. We have to insert 0.01, no, 0.1. Okay, this is perfect. Proportional fall-off, not smooth but linear. Okay, now we can apply a modifier, but only for these vertices. So we have to add in the vertex group selection these vertices, assign these on it, go to modifier, tab to exit from the edit mode. Now we have to apply an array to have a multiple version of these nodes, 5 in this direction and one other array, 5 on the other direction. Okay, so 1.5 and 1.5. Okay, 25 nodes, but they are similar, so we can have a displace, new to create a new texture, button to choose what texture you want to apply, clouds. So we have to go to modifier and decrease the strength of these displays a little bit, and filter only the group, okay, the vertex group we created. In this texture we have to decrease the size, okay, of these displays. Go again in the modifier and decrease the strength to 0.01, divide by 2. Okay, perfect. We have 25 nodes. Post-it different. We have to save our project. We have the nodes. We have to separate these nodes, so we have to apply all these effect, tab to enter in edit mode, A to select all, P to separate by loose parts to have all the nodes separated. Tap to exit from the edit mode, right button, set origin, origin to geometry. Okay, hide nodes, go to the collection, to the surface collection, Shift A, mesh, cube. Okay, this is our room, rename, room, tab to enter in edit mode, 3 to face a selection, click, shift, click and click, delete, face, and okay, A to select all the faces, go upright and view face orientation to view the normal, then Shift N to invert the normal, okay, of the faces of our room. We will use this after in the geometry notes. Tap to exit from the edit mode, and we can create a Shift A, another mesh, so we can add a Suzanne S 0.3, enter. So add the modifier, subdivision surface, to level, right mouse button, shade smooth, upright, and turn off face orientation. And these are the objects, okay, the surface where we want to instance our nodes. Okay, now go to geometry nodes. We can create, close the collection, select the scene collection. We add a simple plane to manage the geometry nodes. Add new geometry nodes, so we can drag and drop the entire surfaces collection and the nodes collection. So we have to distribute point on faces. On what? On this geometry. Shift Alt click to filter only this selection. You can see the point on these surfaces. Select Poisson disk to have a minimum distance from each nodes that we want to add on these surfaces. We can increase the density. Okay, we can drag this collection for the input collection to manage it from the outside of geometry nodes word. We can drag, or we can also drag the collection of nodes, and we can simply rename it in surfaces and these nodes. Okay, you can add whatever you want in this collection and this collection, and the geometry nodes will apply these objects on these surfaces. Okay, we have to choose these relatives, separate children, reset children, to have a separated origin of each object's nodes. If you forgot to set the origin in the center of each geometry, okay, the pivot point on each geometry of this collection. Okay, we can instance on these points this collection. Pick instance, you have to check pick instance to let it to choose all the objects, okay, by index. The first node here, the second here, the third here, etc. Shift Alt click, and there are nodes, but the rotation is wrong. We have to align the rotation with the normal of each faces. Okay, so we can use Euler Line Euler, okay, use the normal as a vector, link to the rotation, and use a different axis. Okay, the alignment is correct. Want to go to the front orthographic view, Shift Z to see the wall and the notes. We have to shift a little bit of a little value of normal, okay, of each faces where the notes are. So to shift this point we have to set position. We have to set position before the instancing. We can use vector math. We can use it like an offset and drag the normal of the same faces, scale, Shift Alt and click to see the result. You don't see anything. Why? Because we have only the information about a single object here and a second object, Suzanne. We need to realize instances in this mode to have all the points we want, okay, to shift. And now you can decrease the value. Want to go to top view. Oh yes, 0.03 maybe. Now we have to simulate the scaling from 0 to 1 of each nodes using a fall-off effect. So we need to add in this project a controller, okay, a fall-off controller. So I can rename this in geometry node. I can Shift A, add an empty sphere, okay, name it controller, select the nodes, so I can drag and drop the controller in my geometry nodes and duplicate the group input node and add an object as an input, name controller. Okay, so I have to calculate the distance from each point, and for this we need to capture. It's better. We need to capture what? A vector for each point, for each instance, the position, the end position, okay. These are the end position of each node, so I can use this to calculate vector math. I want to calculate the distance from this position, and the location of my controller. I have to normalize this value. To do this, I have to apply a math operation. I have to divide the result with a scale to have more flexibility of scaling of each node. Okay, more big is the controller, more speed we will have on scaling the single node. More small will be the controller, more slowly the scaling will be. So I have a number, an array of a number. I have a diamond dot. We have to link this value to the scale. This is the result. Select the controller, G to move, and yes, this is the effect, but we want the exact opposite. Okay, we have to invert the scaling from 0 and 1 to 1 and 0. Okay, right button, map range, add the map range from 0 to 1 to 1 to 0, and clamp it, because we want the scale of our nodes always to the end scale, to the end original scale, not more big. If I move the controller, we have the scaling. Okay, we can increase the density to see better the result, and decrease to 0.1, 0.05. Okay, we can drag the density and the distance to have more control outside the geometry nodes, so we can have this effect. But the scale of our empty controller is too small. We have to scale it, and scale 10, and now press G, Shift Z, and you can see the scaling. Okay, the scaling of our node. Now we want to animate the position from a common original pivot point, like a particle emitter, to emit the nodes from this point to the end point, okay, on our surfaces. To do this, we need to add with the Shift A another empty, rename emitter. We can drag it on our geometry nodes, save the project. We can move these a little bit, Shift A, layout, frame, F2, controller, fall off, drag all the nodes inside of it to make the layout better, save the project. And now we have to set the initial position of each point of our realized instances. Okay, I move the scale here, and now I move the Euler rotation, Shift right, drag right button to create a dot, G to move. We can duplicate the input and use it to link the collection of nodes we want to instance on our points. G to move, here, instance, voila. Now that we have the emitter object, we have its location, and we have to mix what? Location of this emitter and the final position of each point, okay, using color as the position. And this is the result. Moving the factor, you can see the position that slide from 0, from the location of the emitter, to the end position of each nodes. We could manually adjust this factor, but there is a better method. So we can use the output of our fall off controller as the factor. Okay, and now if I select the emitter, G to move, Shift Z to move away, I can select the controller, go to one frame, 7 key to top view. I can move a controller here, for example, press I and keyframe location. So in the layout I can go to 120 frame, limit to 120 in the animation, select the controller, set the position to 0. I, to save the location information to this frame, go to Geometry Notes, select Geometry Notes. We can move the view, and we can shift left arrow to go to the start animation, play the animation, and you see the result. Now you can see a weird effect. All the nodes have the end normal, okay, but this sucks. So we can rotate each nodes from a random value to the end rotation that they need to have, okay. So we can use always this factor, okay, this result of a controller fall off, to make a rotation. We have the normal rotation, okay, the normal rotation, the end rotation. We have to slide from a random value, vector random value with a map range from 0 to 1 to 0 to 2 multiply pi, so 360 degrees, but in radian 2 pi. Link the result to the max random value as a vector, and add with the shift control right mouse button, drag these two nodes. The system will add a mix node, okay, and now you have 0 random rotation and maximum rotation. So we have to clamp these to avoid to go over the limit information that we have in this node, and we have to assign an opposite value from 1 and 0 to 0 and 2 multiply pi, because we have these as a factor and we want to have 0 rotation when the fall off is 1. When the fall off is 1, we have 0 rotation, so the end of the animation. When the fall off is 0, we need the maximum random rotation, so 360 degrees random value. And now if I press play, we have the correct result. Go to layout, and we can see the rotation, the random rotation, and the scale that born in the position of our emitter, and slowly goes to the normal rotation and the final position on our surfaces. Okay, so removing the controller empty and the emitter empty, and you can manage as you want the effect of the fall off and the source position of the effect. So I can select this geometry, go to Geometry Notes. Now we can make these layouts more readable, and you can also add with a Shift DD to duplicate group input node. Click Alt P to separate this group input, move it, and add the emitter object. We can rename emitter and shift a little bit. Okay, so a moment, and voila, this is the result. So we have a collection of surfaces. We distribute points on these surfaces, more surfaces. We realize these points Ctrl Shift click to have 4,600 points. We have to capture each position of these points to use with a control fall off. We have a controller object that has a location, rotation and scale. We use the distance from each point and this location divided by the scale to have more flexibility with a scaling, with a fall off effect. We map range this effect with an opposite value, okay, from 0 to 1 to 1 and 0, and from a random minimum value to have little offset effect for each nodes on our surface. Then with this geometry we use this result of this fall off as a scaling, okay? So when the animation starts the scale is 0, and when the animation ends the scale is the maximum value, so 1. We have an animate position, so we have an emitter that we use to mix the position for all the nodes from the location of this emitter to the end position on our surfaces, okay? Thanks the factor. What is the factor? The factor is the controller fall off output, okay? The same values. So after the set position we have a simple offset to avoid a collision from the nodes and the surface itself. Then we have to instance our nodes with a collection of nodes that have the scale described and a random rotation calculated by the fall off controller result mapped to have a maximum of 360 degrees, random values from 0 to this number, and added to the original end rotation of our nodes. Stop the animation, save the project, and we have to apply a material now. Set material, simple material. We need to go to material, new material, node, choose node to assign the material, go to shading. We can simply add an RGB value, a little yellow, okay, link the color in the base color of principal object, increase the roughness, and we can add a simple bump effect. So we can use a noise texture, Ctrl T to have texture coordinates, G to move, scale it, use object to vector, use this vector output as the height of a bump, link the normal output to the normal, okay, decrease the strength to a little number 0.034 to have a little bumping effect. So we can adjust, okay, the bump effect on each node. So we can assign a simple material to our room, F3, checker texture, link color to base color, add the material to Suzanne, make it completely metallic, go to layout, in the upper right corner click to the view shading to display the texture and play the animation, and voila, we have the result. This is the tutorial. Thank you guys for watching this tutorial. I hope you enjoyed it. If you want, you can leave a comment, check a like and subscribe to my channel. You can find the project on my Gumroad page. You can download it, and see you in the next video.